1.3. Einstein's interpretation of the photoelectric effect. Let's begin. The concept of quantum. As we know, all things are divisible until we reach the level of atom. And yet, even atoms can be divisible. What about energy? Can we divide energy into very small units as small as we want? Quantum refers to the concept that the amount of energy can only increase in steps, but not in any arbitrary manner. Let's talk about pouring milk into the cup. It seems that we may pour any amount of milk in a cup. In fact, we cannot. There can be 1 billion or 1,000,000,001 milk molecules, but it cannot be 1.5 billion milk molecules in a cup. In other words, amount of milk in a cup is not continuous, but quantized. 1. Light as particles. Photons. In photoelectric effect, the stopping potential for the given metal surface only depends on the frequency of incident light, which means the kinetic energy of a photoelectron depends on the frequency of the incident light only. To explain that, Albert Einstein considered light as packets of energy called photons. So light is also quantized. The energy of a single photon depends on its frequency. In other words, each photon carries a quantum of energy. The energy carried by a photon is given by E equals hf, where h is called Planck constant. When there is a photo emission, the energy of a photon is absorbed by an electron, which may then escape from a metal surface. Example 2. Energy of photon of red light. The energy of a photon of red light can be calculated using the formula E equals hf. This energy can be expressed in joules, but better be expressed in electron volt. Better because electron volt is a smaller unit, which is more appropriate for small energy. Intensity of light is the amount of light energy through each unit of area per unit time. In this way, the intensity of light incident on a surface will be directly proportional to the number of photons hitting the surface in each second. Mathematically, we may express intensity in this way, which is the number of photons hitting the surface per second divided by the area of the surface. Example 3. Number of photons hitting a surface in each second. When the intensity of light is given, you may find the power of light reaching a given surface, and then find the number of photons arrived for the given frequency of light. For the given frequency of light, the intensity of light increases with the number of photons hitting the surface. On the other hand, when the intensity of light is constant, the product of the number of photons per second multiplied with the energy of each photon should be constant. When frequency increases, the number of photons reaching the surface per second decreases accordingly. And vice versa. Do check point 5 below.